solving linear equations using Cramer's rule. Cramer's rule is basically using determinant, and determinant provide a very good tool to solve the linear equation, small linear equation like this. And in the programming, probably we use a different method to write a computer program to solve the linear equation, but for manual calculation this is very useful. Okay, so for manual calculation, first of all we need to understand determinant. Determinant is an array of number a1, let's see, basically coefficient a1, a2, a3, b1, b2, b3, c1, c2, c3 equals d1, d2, d3. Now we create a determinant, means this 2 bar, and we put the array of coefficient in the equation. And the rule is actually for this 3 by 3, we have a positive side and negative side. The positive side go this way. This is the first term, this one, and this is the second term, which is this one, b1, c2, a3, and another one is this way. Okay, now negative side we go this way, c1, b2, a3, and b1, a2, c3, and a1, b3, c2. Okay, so that's a kind of method to calculate the 3 by 3 determinant. Okay, now when a1, a2, a3 is equal to b1, b2, b3, or c1, c2, c3, or c and b, these columns, they are equal, then determinant is 0, and that can be proven very quickly, easily. Now it doesn't have to be column, it can be row. Okay, if this row's same as this row, then determinant is 0. Okay, so that's the first characteristic you have to know. Let's go over a little bit determinant characteristic. Now a1, a2, a3, b1, b2, b3, c1, c2, c3. The real definition of breaking down this determinant is you pick row or column. Say we take this row, then a1 is going to give this determinant b2, c2, b3, c3, and next one minus b1, then it's give this because it's exclude this and this. Okay, so b1, a2, a3, and c2, c3, and plus next one c1, again we exclude this and this, so a2, a3, and b2, b3. Now this determinant is broken into b2, c3 minus c2, b3, because same rule apply. When you take, this is the remaining, and if you take next one, then this is the remaining. So that's the way it's broken down, same way. So basically, if you have n by n determinant, we can break down by one column and break this one again and again. So any kind of array can be broken into the regular expression. Okay, now when you have, let's see, constant multiply, say x, okay, this is gonna be same as multiplying x to one row, one of them, or one column, either way, because x shows up on every one of them. So you take one row or one column, the multiplication of constant value to the determinant is going to be showing up in every one of column or row. Okay, for example, delta 1 is defined by d1, d2, d3. The a1 is replaced. You go back to this equation. These are the d1, d2, d3, and instead of this we plug in this one. That's delta 1. Delta is the coefficient of this. Delta 1 is the first column is replaced with d1. Since d1 is this equation, now determinant, one more characteristic of it, determinant, say a1 plus a1 prime, a2 plus a2 prime, a3 plus a3 prime, b1, b2, b3, c1, c2, c3 is the same as a1, a2, a3, b1, b2, b3, c1, c2, c3 plus a1 prime, a2 prime, a3 prime, b1, b2, b3, c1, c2, c3. So this addition, one of column or row, can be broken into this way, two determinant. Okay, so using that, going back this one, this is gonna break into this part, and this part, remember this will be same because y can come out determinant, then it's gonna be 0. This part, two columns are same, so after z come out, it's gonna be 0. Only this one left. So if you put the x out, then it's become like that. That means x delta. If this is x delta, the x1 is this, then x is given by delta 1 over delta. Okay, we do same thing. X delta 1 is the d's here, delta 2 is d's here. We do the same things, repeat. Then y become delta 2 over delta. So when you have linear equation, the small size like that, and say what is x? Well, x is given by this. Very quick, just calculate the determinant delta and delta 1. Again, delta is given by this, and delta 1 is given by this. So you use this formula to calculate, then you get x right away. Okay, so it's kind of very quick way to find the one unknown value using the determinant. That's the Cramer's rule. I hope you enjoyed listening to this video. Please check other videos, and if you like, subscribe.